I'm a self-taught senior AI engineer, and I've been in a lot of AI engineer interviews on both sides, as the interviewer and the interviewee. A lot of you found my last video about the common AI engineer interview questions I faced when looking for a job was super useful. And since that video, I've started hiring AI engineers and doing the interviews by myself. So here's an updated video with even more questions and answers that you can use to really show your understanding of the AI engineering concepts and impress the interviewer to help you land that job. Now, one thing I learned from interviewing AI engineer candidates is you don't need to answer everything perfectly. Most candidates I've had interviews with, they might go through the whole interview, and my perception might be that they're kind of like a meh candidate. And then I ask them a certain question and they answer it very well. That could really carry their candidacy and make it much more likely that I will advance them to the next round. Conversely, if a candidate does very well throughout the interview, but they fail on a certain concept that is very fundamental, it can really make me question their abilities as an engineer and make it less likely for me to advance them, even if they've answered all the other questions really well. This might seem a bit petty, but there really are some core concepts that if you don't understand them, it can be kind of tough to evaluate if you're qualified for a certain position. In this video, I will share with you both these types of questions, and I'll let you know if it's one of those fundamental questions you should learn or a nice to have one. Okay, so let's get started. Now, this first one is definitely a nice to have, although if I could choose, I think everyone applying for an AI engineer position should know the answer to this, but so far only like 1 or 2 people have been able to answer it. How do LLMs work? I mean, hey, you want to work with LLMs, right? Well, you should at least understand how they work. An answer I'm looking for here is, large language models. They are a probabilistic next token prediction. So large language models use something called tokenization to break down the text you give it into chunks called tokens, and then into numbers, which are called embeddings. And then this is passed through a transformer, which will look at the mathematical relationship between your tokens to understand context. For example, a bank can mean a place where you get a loan, or it can also mean a riverbank, depending on the surrounding words. This is what a transformer does. After that, the model outputs a bunch of tokens with a probability score, with the highest one being the most reasonable next token in the sequence, based on what you fed it. That's kind of like a very detailed answer of large language models. I mean, you can just answer they're kind of a next token prediction machine. They're trained on a lot of data, mainly from the web. If you'd like to learn more about that, I actually made a video about how large language models get their data. Very interesting stuff. And if you can mention transformers, that's even better. Another nice to have is, how do transformers work? So transformers are a technology that completely revolutionized natural language processing. With this, we can basically process an entire sequence of text at once, rather than one word at a time. And this allows us to train models incredibly faster than before. And this allows for a process called self-attention. And this allows the transformer to kind of look at every token in, let's say, a sentence that you feed it, and calculate how much attention it should pay to the other tokens in that sequence. And this is so that it could understand the context. Like I said before, a bank can mean, at least 2 things depending on the surrounding words. And the transformer architecture is kind of what enables this. Now, this is a question I got before that I thought was quite interesting, is how would you design a workflow to remove all that links for hundreds of client websites, assuming you have API access to overwrite their HTML? Now, you might be wondering, what is this question doing in here? Well, it kind of pertains to this very brand new concept called AEO, Answer Engine Optimization, which is, I guess, the sequel to search engine optimization, because people are using less and less search engines and more answer engines like ChatGPT. So this is why it's quite important. There's also a lot of jobs that work within AEO. So I think, knowledge of how you can build a system to facilitate things within AEO, quite beneficial. So it's a bit of a system design question, but you want to parse a bunch of blog posts, identify any dead links, and then remove them and maybe even replace them. What's interesting here is usually in blog posts, if the link is dead, then a lot of the surrounding text will be kind of referring to that link, which means if you remove that link, you kind of have to change the body of the text itself. So how do you do it? Well, you set up some sort of workflow that parses or scrapes a bunch of blog posts, maybe through an API, or maybe you set up a web scraper. Then maybe you can parse the HTML using a library like Beautiful Soup, or you can just regex out the anchor tags, see if they have any links, extract the link. And now to check whether a link is dead or not, I mean, you could do like a GET request, which will return to you the body of that link. But actually the conventional way is to do a head request. The head request will tell you whether the link is dead or not. If it's dead, you of course remove the link. You record the position in the HTML document of where this link was found. And then you maybe make some overlap where it's like the 50 characters before it and the 50 characters after it need to be rewritten. You feed the whole text, and you feed that chunk of data into the LLM and ask to rewrite it, telling, a link was removed, rewrite this so it's not dependent on the link. So I guess once I describe it, it sounds kind of easy, right? But these are the things where if you get a question like this, you need to start thinking about a process, a workflow, and each step you need to do, each special consideration to get to the desired outcome. And the best solutions are often simple, but they can be quite hard to conjure up, to think about. So it's a good exercise nonetheless. Okay, and here's a part that's a bit more technical, testing your Python, maybe your backend programming skills. How do you handle race conditions in your code? I would say this is quite a fundamental question. Race conditions happen a lot in AI engineering due to the nature of asynchronous programming. So I really expect you to have an answer to this. Now you can use a lock or mutex as they're called if you want to sound really fancy, I guess. This is the most common approach in Python at least. So use a threading.lock. Basically, once one thread tries to access a variable, it checks if there's already a lock. If not, it will access the variable, slap a lock on there, and once another thread tries to access that variable, it needs to acquire the lock. It's kind of like when you're at a rave and you try and use the porta potty and you open the door and it's like, it feels like you can kind of like, if you use enough force, you can probably open the door, but like it's locked, like someone's already in there. Like you have to wait your turn, dude. So basically only one process touches the data at a time. You could also use immutable data structures like a tuple Python. It's basically a list that cannot, once it's instantiated, it cannot be changed. And once you pass it around, for example, this will force people to copy the tuple if they want to modify it. And that's great because they won't be modifying the initial array. They'll be forced to create a new copy, thus avoiding race conditions. All right. Here's another fundamental one that unfortunately I see a lot of candidates not be able to answer. What is something unique about Python when it comes to concurrency? Now, once I say this, the first thing that should pop into your mind is the global interpreter lock. Now, this is a mutex, remember, fancy word for lock. And this basically allows just one thread to execute code in Python at a given time, which means you can't really achieve complete parallelism where multiple lines of code are running in parallel in Python unless you use multiprocessing. But multiprocessing is you're basically just spawning a bunch of different Python interpreters, so that's kind of cheating, But that's something that's a very common and controversial concept of Python. It's very fundamental to how the language works. This is due to facilitating garbage collection. But yeah, you should know about the global interpreter lock in Python and its effect on concurrency. Now, I should also mention, while you can't achieve parallelism, you can achieve concurrency. And that's kind of what asynchronous programming does. Is you can have multiple threads, one is executing, then you're waiting for a network request, then you switch to another thread, do something else, and then when this one's done, you'll. Here's a nice one. What are some problems you can run into when using asynchronous programming in Python? One thing is you can block the Python event loop. So a CPU-heavy task inside an asynchronous loop will freeze the entire application. So asynchronous programming is better done for example, network requests, where you have a lightweight process that calls an external API and waits for it, basically. Also, you have to watch out about using synchronous libraries like time.sleep, as these will kind of defeat the purpose of using asynchronous programming. So for example, using requests is also a synchronous one, so use HTTPX. Also, when you have a bunch of tasks happening concurrently, it can be quite hard and add some additional complexity to debugging. If you ever had to debug an asynchronous code, it can be quite annoying compared to synchronous programming. So just something that's good to bring up, I would say. Also, you can schedule tasks and then forget to await them, which means if that task that you never awaited crashes, then it will fail silently and it will be even harder to debug your application. So when it comes to global interpreter lock, concurrency, asynchronous programming in Python, I actually made a video where I go over 50 advanced Python programming concepts where I go through these in more detail. And you should definitely give it a watch if you feel a bit uneasy about these subjects, because I go through it all in that video with examples. And there's a lot of good nuggets of advanced Python knowledge that you can use to really shine in your interviews and demonstrate that you have a good understanding of Python as a programming language, which is quite important for the AI engineer role. I mean, when I interview, I basically try to look for strong Python programmers, because we're still at a point where we can't expect people to have GenAI experience. So instead, I look for how well does this person know Python, backend, that sort of thing. Okay, next one. How would you handle real-time versus batch processing for data updates? When is one preferred for the other? Again, I'd say another fundamental one. Basically, the first question you need to ask is, does the user need this data right now to make a decision? So let's say they do, which means data freshness is critical in this system. This can be, for example, if you work in a bank, fraud detection, blocking a transaction before it clears. Problems are this is kind of expensive and complex to set up and manage. You basically need to have infrastructure that's always on, that's always constantly receiving data, oftentimes a lot of data. And if a stream fails, then you're losing important data unless you have a solid recovery mechanism like with Apache Kafka. But basically the point is it's usually more expensive and a lot more complex when it comes to this. Now, on the other hand, if data freshness is not critical, then you can do batch processing, where you can take in a high volume of data and delay is acceptable here. This can, for example, be generating embeddings for a knowledge base. This is a job that you can probably do, like have a cron job running every night, and the user is not expecting like data to be available as soon as it is updated. So we have high latency, the data isn't fresh, but it's much more efficient. It's easier to set up, and it's way cheaper too. It's also way easier to debug. And if a batch job fails, we can always just rerun it, right? So given this, the additional complexity of kind of real-time processing, you should always try to err on batch processing as much as possible, unless it's really needed. But it's important to understand both approaches here, because when working as an AI engineer, you'll be working a lot with data. And I would say most of the time, you will be exposed to both of these different problems. All right, next question. How do you ingest and process different types of data? Let's say you work in e-commerce. So you have structured data, which can be the product SKU, so like the unique ID for a product. It can be unstructured data like reviews. And maybe you have user interaction data in the form of events or logs. So for structured data like SKUs and inventory, you would probably use a SQL database like Postgres. Due to the structured nature, this requires strict schemas and ACID compliance as well. Now, when it comes to unstructured data, you can either choose MongoDB or a vector database. I personally haven't worked much with a NoSQL database. I would probably try to chunk a review into different semantic chunks, embed them, send them off to a vector database like Pinecone. But it kind of depends on what they will be used for later, of course. And user interaction data like logs and events, we're talking like a high volume amount of data, like whenever someone does something on your website. So you can expect a lot of data is the key here. And these you can store in a database just like the others, but remember, we're gonna have a lot of data coming in at once. So as to not overload the backend, maybe you want to use a message queue, maybe Apache Kafka. But if you want to avoid that complexity of managing that system, you can use a ClickHouse database. Now, ClickHouse is basically a SQL database that is designed to handle a lot of incoming data at once. And it's very good at this and very useful in AI applications, especially when it comes to event data. So I highly recommend you checking out a ClickHouse database, familiarizing yourself with it, maybe even doing a project with ClickHouse. So because ClickHouse has great compression, it saves you a lot of money on storage when you're storing a lot of things. And it can basically handle like millions of rows per second. So it's perfect for this. How do you ensure the quality of data that an LLM interacts with? A first one is the duplication. This is something an AI engineer will do a lot in their job. Let's say you're building an agentic application for a knowledge base inside of a corporation. You'd be surprised at how many internal documents are just copies of each other, maybe with different dates or timestamps. So a good way to dedupe them is hashing, turning a whole document into a unique hash, seeing if it already exists. Now, you can use algorithms like minhash or Jacquard similarity, which will break the text into small sets of words called shingles, weirdly enough, and then calculate the overlap. And you can have a threshold. If it's over 90% overlap with existing documents, you discard it. Or a faster way is you embed everything and then you just take the cosine similarity of whatever is existing. Or you can also embed it and just do a basic retrieval where you get the mathematically closest documents already in the database and you just compare them. How similar are they? If they're very close, then you can probably discard them. There's also normalization is very important. Let's say you have a financial agent that has access to different financial documents, and some of them, all the numbers are listed in millions. So if you see a 5 on there, it actually represents 5 millions. Another document, it will show the real number. So a 5 there is actually $5. You would need to then normalize the data in one document. So it actually says 5 millions instead of 5. That's very important so you don't compare 5s to 5s. Or if you're parsing HTML pages, you can strip out messy HTML tags that might just confuse the tokenizer and aren't really needed. So that's a way to make the data a bit cleaner. Okay, next question. How would you efficiently generate and store embeddings? Let's use the example of products and queries in a chatbot application. Again, sticking within the realm of e-commerce here. Thinking about when you hit an API to get a product, the types of fields you expect to receive, maybe title, description, the quantity available, and the price. Then think about how will the user use the application. So this is a chatbot application. They'll probably be searching, oh, I want red pants, or I'm looking for this type of sweater, right? Based on that, you can probably skip certain fields like SKU. I mean, if the user knows what SKU they want to search with, it shouldn't be a vector search at all. It should be a keyword search. So skip that field entirely. You can probably skip price and quantity available, as these would kind of just confuse the LLM. Vector search is for semantic meaning, not math. So that's kind of why we're skipping quantity and price. And what you do want to embed is like title, other features, and the description that give the product a semantic, description. Now, what you can do is also take the original query and rewrite it to make it more appropriate for an LLM. For example, let's say you have a conversation where first it says shoes, and then the user says red ones. They're obviously referring to red shoes. So take the last message called red ones and combine it with the history and turn it into red running shoes, for example. And this will make the retrieval step a lot easier. Now, in other chatbot applications, let's say if you're looking through company documents and not products, you can use something called hide, which is hypothetical document embeddings. Basically, you'll take a query and you'll generate a fake answer to that query. And then you'll search through the vector database with the answer. And what you'll find is this oftentimes will match the answer better than the question itself. Because of the nature of a question versus an answer, they're kind of two different things, right? And semantic retrieval is usually based on how similar are two strings of text. I personally haven't used this method, but I've read a lot online about it being an effective way of increasing accuracy and retrieval. Okay, how would you handle the problem of a model hallucinating when no information is found in the given context? Handling hallucinations, definitely say this is a fundamental question. Now here's an example. Let's say you ask, who is the CEO of this company? and you have no documents that answer this. And there were no documents in training, and there's no documents that can answer this. So the model just responds Steve Jobs, because based on the model it trained on, it saw that's CEO Steve Jobs. What you can do is you can look at the cosine similarity score of the retrieved documents, and under a certain threshold, you can just discard them. Or maybe the knowledge base has the document where it says Steve Jobs, CEO, but it doesn't refer to the company you're asking about. So let's say you discard all documents, and then you don't even need to call an LLM. You can basically just say you don't have that information, which will save time and money. You can also just pass a very strict system prompt, something like, you're a truthful assistant, answer the question using only the provided context chunks below. If the answer is not explicitly written in the context, you must state, I do not know. Do not use outside knowledge. This usually does the trick. What you can also do is sort of a post LLM check, where you have citation enforcement for every claim that the model makes. And then you have some code that post processes the output, and basically if there's a claim without a citation, then it will be removed or it will be flagged. Okay, what steps would you take to handle exceptions in a GenAI application? I'd say this is nice to have one. If you understand exception handling in GenAI, I'd be quite impressed. One thing here is to have strict timeouts and retries. Basically, don't let an LLM call or API call be there forever. Use exponential backoff. So first you might wait for 2 seconds, then 4 seconds, then 8 seconds, etc. That way we don't hammer a certain API and get rate limited, which is easier than you might think, especially if you're hitting OpenAI through Azure, God help you, then you can get rate limited quite fast. Also use fallback providers and models. Let's say you're hitting Azure OpenAI because you have credits through like a starter program or something. Well, let's say for some reason Microsoft goofs and the Azure API is down. Well, then you can fall back to just hitting the OpenAI API directly, even though you might have to pay with your own money. Maybe a certain model or deployment is unavailable. In that case, you should have a fallback model. Also, make sure you fail gracefully. So don't show these convoluted error messages to your user where it's like type error because this variable is the wrong type of variable, blah, blah, blah. Make sure you just catch the errors and return something clean. Like, I'm having trouble thinking right now, please try again, if it's a chatbot application. Now here's something I call the triple dipper. So in traditional programming, you have the CAP theorem, which is consistency, availability, and partition tolerance. The idea is you can't have all three, you have to sacrifice one to get the other two. In GenAI, I would say we have a similar triangle for latency, costs, and retrieval accuracy or relevancy. And it's important you know how to optimize each one. So how do you manage all three of these? I guess let's start off with, how do you reduce latency? I'd say a good first step is caching common requests. And what you can do is you can route your API calls through Cloudflare AI Gateway. It will cache them for you for free. Super nice. You can also use semantic caching, which means the prompt doesn't have to match the cache exactly to be cached. And this is nice, but it might reduce relevancy here. You can also use smaller models for simple tasks like summarization, and save the big models for complex reasoning. This also reduces cost, but it may impact relevancy in a bad way. You can reduce the embedding dimensions of your vector embeddings as well. Again, might impact relevancy. What you find is a lot of things that reduce latency will also reduce costs. So how do you reduce costs? Well, you can do prompt engineering, where you cut unnecessary words from the system prompt. Just remove excess instructions. If you have a big prompt using a big model, maybe you can split out some of the easier tasks to a smaller model and call them after each other. Best case would be if you call them in parallel to save on latency, but if not, you have to chain them, and this might improve latency. It also might decrease it, depending on if you have the appropriate model for each task. It's quite hard to say, but I've experienced both. Okay, and then relevancy. So let's say you have a RAG retrieval application. You'll most likely, once you retrieve certain documents, have some sort of AI as a judge, where you take all the retrieved documents, pass it through another LLM, where it takes the original prompt, the retrieved documents, and looks at it one last time and is like, hey, is this really relevant? And then filters. You'll find that this prompt can often be the most costliest, because You have to give it instructions, you have to give it a bunch of context documents and the query, and it has to run a lot. Instead of using a large language model, you can use a re-ranker model, which is way smaller, cheaper. So I guess here you're not really increasing relevancy. The AI as a judge is a measure you're taking to increase relevancy, and this is just a more efficient way, both in terms of latency and cost, to achieve that. So maybe hopefully you can achieve all three here. The re-ranker model will return a similarity score for each input, and then maybe you can have a threshold where if the similarity score is high enough, you basically make it skip the LLM as a judge. So you just return it to the front end. You can also tune up the, for example, reasoning effort. Some models like GPT-5 have this. You can ask the model to think step by step before answering. This costs way more tokens and it takes much longer, but the reasoning quality is significantly higher usually. Awesome, so those are the questions I've discarded since my last video. Both questions I ask myself in AI engineer interviews. I really hope that helps. Make sure to watch the first video if you haven't watched it already. It seems quite popular. It's helped a lot of people. I do have some additional general tips about how to behave in an AI engineer interview to make a great impact. Basically, just talk a bit more about what people look for when hiring AI engineers. So make sure to watch that video. It should be up here. Thank you so much for watching, and I'll see you later.